I've started a new series, Retro Networking. I want to teach you about the history of networking and show you practically what happened in the past. I've seen a lot of people talk about 10base5 as an example using PowerPoint presentations, but I haven't seen anyone build a 10base5 network and practically demonstrate it. That's what I'm going to do in this video. I've created a network using a Windows 3.11 laptop and two Windows 98 PCs. I'm going to show you practically how 10base5 works. We're going to look at the cabling. Here's an example of a 10base5 cable. This stuff is very difficult to work with. 10base5. Notice these black markings on the cable. This is where you had to insert a transceiver. A transceiver such as this. This transceiver has what's called a vampire tap or network tap. So you would take a transceiver like this. This would be connected to this portion of the transceiver. Here's the vampire tap that you'd need to use. You'd have these screws that you had to unscrew. Crazy old technology. Can you imagine us having to do this today? You had to cut a hole in this cable on this black portion, and then you would insert the transceiver, and that would give you a connection to the network. Really old technology. Now, if you've ever wondered why this is called Thicknet, notice how thick this cable is. Very, very difficult to work with. Here's an example of Thinnet. Much easier to work with, much smaller cable. So here I have an Ethernet cable, 50 ohm, thin Ethernet coax, we're told. It's got BNC male-male Ethernet connectors. It's 15.2 meters. We can see at the back here how we should connect our devices. So we're shown as an example that we need T connectors, we need terminators on the end. But notice how thin this cable is compared to Thicknet. So this is 10base2, also called Thinnet. Notice how thick this cable is in comparison. I think it's quite obvious why this was called Thicknet and this was called Thinnet. I mean, you can just see the difference in the size of the cable. Today we would use something like this. Here's Cat5 cabling. Here's Cat6 cabling. Much easier to work with UTP cabling or unshielded twisted pair cabling today than it is to work with 10base2 or 10base5. Notice the size of this terminator. This is a terminator in 10base5. Here's a terminator in 10base2. 10base2 transceivers were also quite large, similar to 10base5. So 10base2 here, 10base5 over there. But then they got a lot smaller. So here's an example of a more modern 10base2 transceiver compared to a 10base5 transceiver. And then we have UTP or RJ45 transceivers. So here's a Cisco transceiver that you would insert on an AUI connector on a router as an example. Modern transceivers look like this. So this is an example of a fiber transceiver that would go into a switch, also known as an SFP. So notice how the technology has changed over time. We've moved from something like this, very, very big, to something a lot smaller today. So why is this called 10base5? It's because 10 means 10 megabits per second. That's 10 megabits per second shared across this cable. So if you had two devices, they are sharing 10 megabits per second. If you had 10 devices, they are sharing 10 megabits per second. And in the old days, you only actually got, say, 30% utilization of your network because of collisions, so you could never actually get 10 megabits per second. The more devices that you put on this cable, the more collisions you would take and the more contention for the cable because it's shared. So the full speed was 10 megabits per second. 10base5, the base means baseband rather than broadband. This is a shared medium. Only one signal can traverse this cable at a time. Now this Thinnet is called 10base2, Once again, 10 megabits per second, baseband, only one signal across the cable at any given time. This is known as 10base5 because the cable length could be 500 meters. So that was the maximum segment length or the maximum length of a cable. This is known as 10base2 because the maximum cable length is 200 meters. It's actually 185, but they just made it 2 for 200 meters to round it up. So we have 10base5, 10 megabits per second, baseband, shared medium, 500 meters, 10base2, 10 megabits per second, shared medium, baseband, 185 meters, but rounded up to 2. And then we have 10base-T because this is twisted pair or unshielded twisted pair cabling. So here we have UTP or unshielded twisted pair, 10base-T. Here we have 10base2, and here we have 10base5. Hopefully those terms make sense. So 10 megabits per second baseband rather than broadband. Broadband would allow you to have multiple signals across a cable at a given time. That's actually used on coax cables today. So if you've got cable television as an example, using broadband, so multiple signals can go across a cable at a given time, but this is baseband. Only a single signal can traverse this cable at any given time. So 10base5, 10base2, and 10base-T cabling. There are different types of UTP. This is an example of Cat5 or Category 5 cabling. This is an example of Category 6 or Cat6 cabling. The higher the category, the higher the frequencies, the higher the throughput basically on UTP. But hopefully that explains what 10base5 is versus 10base2 and 10base-T. This is once again known as Thicknet because you can see how thick the cabling is. Thinnet because of how thin the cabling is. UTP, unshielded twisted pair, is what we use today. Now, in a lot of network diagrams, you'll see something like this, where a PC is connected with a cable to a network, something like this. So here I'm running a 10base5 network. The reason why we have this cable connected to a bus network with terminators on the end like this is that this is called a drop cable. So in reality, the way that actually works is we have a drop cable like this. So this is a drop cable that you would connect to your transceiver. This would be connected to the cable. So with the vampire tap going into the cable, as an example, here's an example of another implementation. This is a digital H4000 Ethernet transceiver. Notice the size of this thing. It's crazy big compared to, for instance, a modern transceiver like this. This is a SFP that would go into a switch as an example. So notice the size difference is massive. So here's my 10base5 cabling, vampire tap into the cable. This is a Cabletron example with the vampire tap there. This is the drop cable that you would then connect to your Ethernet card. So here's an example. Let me take this one. This is a PCI card. Here's an ISA card. So these are two types of Ethernet cards that you'd put into your PC. ISA, so older technology, PCI, more modern, still very old today. But what you'll notice here is we've got RJ45, AUI, and BNC connector. So as an example, if we're using 10base2, we would connect a T connector to that, and that would give us access to the network. You never connect 10base2 directly to that. So you would never do it this way. That doesn't work. You have to use a T connector on 10base2. But on 10base5, what you would then do is take your drop cable, and the drop cables could be quite long. They could be 50 meters as an example. So here's my network card that would be in my PC. I would have a drop cable like this to my transceiver, which then, as an example, would be connected to the cable like this. So I would literally use a tool, which I'll demonstrate later, to cut a hole in the cable and pierce the cable with the vampire tap, and that's how it connects to the network. So very old technology. Once again, this stuff was very difficult to work with, but that's an example of a drop cable. That's why we have this here. So this would be my drop cable. This would be my bus network. It's a bus because it's one long Ethernet cable So behind me, I've got 3 PCs. I've got my Windows 3.11 laptop. I've got 2 Windows 8 PCs, and I've got a 2500 series router. That's the router at the bottom here. This is the end of my Ethernet cable. So I'm going to be connecting the router to 10base5 using the drop cable and my transceiver onto the 10base5 network. So that's the connection over here. But I've also got 2 Windows PCs, one using a vampire tap directly into the cable and one using an intrusive transceiver where basically the cable is connected to the transceiver and then a second cable is connected to the transceiver to give me a network. But that would be boring just to have a 10base5 network. So what I've done is the 10base5 network is connected to my first router. So here's my drop cable once again to the Ethernet transceiver onto the Ethernet network. So Ethernet 0 on the router is connected to 10base5. Ethernet 1 on the router is connected to 10base2. As you can see over here, 10base2 transceiver, 10base2 cabling. I've got my T connectors onto the transceivers, which will allow this router and this router to communicate across 10base2. This router is also connected to an Ethernet network that's actually connected to a switch, which is on my table over there. So this switch, Ethernet switch, is using 10base-T to connect to router 2, this middle router using 10base2 on Ethernet 1. Ethernet 0 is using 10base-T, and that connects me to a Windows laptop over here. Also connects me via wireless to my MacBook. That means that my MacBook can control the Windows 98 computers, as an example, and the Windows 3.11 computer through wireless, through this Ethernet network, through 10base2, and then 10base5. So I've got an extra router here, 2500, that's just connected using 10base-T. This switch connects through my home network to a 1941 router, which then connects me to the internet so that those devices can have internet access. So here's my 10base5 topology. It's using subnet 10.110/24. Windows 3.11 PC or laptop has IP address 10.111. First Windows 98 is 10.112. Second Windows 98 is 10.113. Router has this IP address 10.11254. 10base2 network's very simple. It's just basically those 2 routers connected to each other. So router down here, router 1 and router 2 are connected using this 10base2 network. They are using these 2 IP addresses. And then I go through 10base-T onto the internet. Now in this example, I'm controlling my Windows 98 computers from my Mac using VNC. This computer on the left is this big computer here connected via 10base5, and this one on the right is this tower over here. So rather than working on them directly, I'm controlling them via VNC. Notice what happens when I open up Notepad on my Mac. That's also displayed over here. So this one on the left is the computer here once again using 10base5. I've only got one monitor connected at the back there, but I've got 2 computers. So as an example, if I open up command prompt and type ipconfig, I can see that the IP address of this computer is 10.112. This one on my right on my Mac, open up command prompt, has IP address 10.113. They also have an additional IP address because there are 2 network interface cards installed in those computers. But this is the one of interest. This is the one running 10base5. So the tower computer can ping the other computer. And as an example, this computer can ping the tower computer. But probably what's of more interest is notice both of these computers can ping google.com. So from both of them, I'm able to ping google.com. And on this computer, I'll open up Firefox as an example. Now it's running quite slow here because I'm using VNC across this 10base5 network, not very quick. Computer resources are also quite low. If I go to properties, you can see that this computer has an Intel 2 processor and 160 meg of RAM. Not gig, meg of RAM. Very slow. But there you go, you can see I'm connected to Google using Firefox, and I'll use the command date today to see what the date is. You can see that today is Wednesday, 10th of June 2020, and hopefully you can see it displayed there as well. So there's a Windows 98 computer connected to a 10base5 network connected to the internet. Now for those of you that are more technical, I've got Ethereal installed on this computer. This is the predecessor to Wireshark, and I can capture packets. I'll only capture ICMP packets and click OK. You can see no packets are currently captured, but what I'll do on my Mac is ping 10112, and hopefully we'll see those packets captured. I'll click stop. And as you can see there, I've captured traffic from 192.168.196 to 10.112. This Mac is on a wireless network only and has IP address 192.168.196, which is the IP address that we're capturing. Local IP address of this computer is once again 10.112 on the 10base5 network. I can now view the frames, and if you work in networking, you'll notice that these frames look exactly the same as 10base2 as an example. So we've got the source MAC address going to a destination MAC address. You can see that it's a 3COM card going to a Cisco card. That's because the default gateway is the Cisco router over here. This router is routing from 10base5 to 10base2, which is then routing us onto 10base2, taking me into my home network and onto my wireless network. But to prove the point, here's the router. Show interface Ethernet 0. We can see the IP address is 10.1.1.254. Notice the MAC address ending in 4B04, which is what we see over here on the Windows 98 computer. You can see source IP address is 192.168.196, which is once again my Mac, and we can see that the protocol used, and I'll just make this bigger, is ICMP. Echo request, and then the Windows 98 PC replied back. So we've got an echo ping reply. Source IP address is 10.1.1.2. Destination IP address is the Mac. We can see that we're using Ethernet 2 here. Source MAC address is the Windows 98 computer. We can see that by typing ipconfig/all. We can see that this MAC address is the MAC address in the frame, and that's going to the Cisco router with this MAC address. A router will change the frames from one interface to another. Because we're going from a physical media here of 10base5 to another physical media of 10base2, the router changes the frame, and this router will change the frame from 10base2 to 10base2. Okay, so what I'll do is close some of these programs down, and what I'm doing here is running older software called PcAnywhere, which allows me to control this Windows 3.11 laptop. Now, if you thought that dark mode was something new, notice this has been around for many, many years. There's light mode, there's dark mode on this old Windows 3 laptop or DOS laptop. But notice, as an example, I'm controlling that computer through PcAnywhere, which is running on my Windows 10 computer. Here I've got a DOS prompt. I'll ping google.com. And as you can see, I'm able to ping google.com from a Windows 3.11 laptop connected to 10base5. I'll show you how this is physically connected in a moment. But I just wanted to show you that I am able to ping the internet from this computer. There's an example pinging cisco.com from Windows 3.11 across a 10base5 network. This is how I'm connected to the internet using this laptop. Now, as an example, I'll do this on Windows 98. So I'll ping google.com with T. Here's the transceiver connected to the Cisco laptop. And what I'll do is just unscrew the terminator, and that'll basically break the network. Now it's saying timeout there. You probably can't see that very clearly. So I'll put that terminator back so that we can see the change. You need to have a terminator on your network. On the router, as an example, we can see that we're getting excessive collisions and the interface went down on the router. Back on Windows, the pings are succeeding after they timed out. So let me do that from my Mac as an example. So I'll clear the screen and I'll ping 10.1.1.2, which is this Windows computer. On the Windows computer, I'll ping google.com again. So I've got ping running on the Mac and ping running on Windows 98. Let's see what happens when I disconnect the terminator. This will bring down the entire network. So this is no longer working on my Mac. When I plug this back in again, we should get our connection back to the Windows computer. On the Windows computer, you can see here's an example that it timed out. I'll just stop that ping, and then it started working again once I connected the terminator. This stuff is really hard to work with, this 10base5 cabling. You can see on the MacBook once again that the ping is succeeding. Now I'm planning a series of videos on retro networking. I've started with 10base5. I'll talk about 10base2, talk about other technologies. I've been able to get my hands on some Ethernet bridges, not switches, bridges. Some really old repeaters as well as multi-port repeaters. Some really old technology. But I don't want to, create all these videos if it's not of interest to you. So let me know in the comments below. Did you enjoy this video? Is this something of interest to you? I'm David Bombal. I want to wish you all the very best.